Now this video is for number 8. Complete the table to determine the effect of the number of compounding periods when computing interest. Suppose $11,000 is invested at 3.7 interest rate for 13 years under the following compounding options. Round answers in the second column to the nearest whole number. Round answers in the last column to the nearest cent. Okay, so you gotta pay attention to this rounding rule. So this column right here, we need a whole number. Annually, N is 1. Quarterly, there are 4 quarters in a year, so N is 4. Monthly, there are 12 months in a year, so N is 12. So we're done with the second column. Now let's go ahead and find the actual value. So I'm going to use a Desmos scientific calculator, and I'll go ahead and just make it to be its, hold on, I want to show you both screens at the same time. So for what? Annual, I don't really need the compounding formula for annual. So you know what, let me start with daily first, daily. So if you are doing a compounding interest, the formula is your principal, 11,000 times, open up a parenthesis, you have to do 1 plus, a fraction comes right here, your APR, which is 0.037, the rate getting divided by the n value of 365, and we're going to raise it to a power of n times t. 365 times, oh, that has to be in a parenthesis on its own, okay, times how often or how long is this investment going to last? 13 years. So that's it for the annual, I'm sorry, for the monthly, or I'm sorry, daily. So 365. So this is the answer. I'm going to go ahead and type this for the daily. And everything else will really be the same. Okay, and I'll show you. Where's my other tab? For the monthly, all you need to do is change this to 12 in the bottom. Everything stays the same. And this 365 changes to 12. This is just the formula that we used. Can't remember what section it was, but I can go ahead and add the formula in Canvas for you. So this is the monthly. And for quarterly, all I need to do is just copy this. But I will change the bottom of the fraction to 4 for quarters, 4 quarters, and this 12 to 4. So this is the answer. And for annually, how many years do we have in a year? 1. So I guess this is just this, or this is the same as doing, just using the, what's it called, the exponential growth function. Okay, you get the same answer, but I'm going to have to round this up to 73 cents. 73 cents. And for continuously, remember we have a different formula. A equals P times E raised to the RT power, right? So that's what we're going to use. So the final ending amount will be the principal of 11,000 times E raised to the RT power. R is 0.037 and what? T is 13 years. So that is how you do your compounding formula. I'm going to go ahead and enter that right here. Hopefully me copying the numbers off the Desmos calculator will be okay. So I'm going to go ahead and just submit the assignment to see. And that was number 8 that we did. So when we go back in, we want to see a check mark next to number 8. Yes, we did. So let me Google search the compounding interest formula for you right here. You know, the formula that we just used. Compounding interest not calculator. We do have a calculator. Here it is. So this is the formula that we used. The final amount equals the initial principal times 1 plus rate divided by n, getting raised to the n times t power. So this is a good formula. I'll go ahead and take a screenshot of this and put it on Canvas for you. If you don't have one from your notes. I think we did, yeah, we definitely went over this. But it's a good problem. That was number 8 on the practice test.